after 0 over 0 and infinity over infinity forms. Now it's time to tackle 0 times infinity and infinity minus infinity. In this video, we will see several problems of limits involving 0 times infinity and infinity minus infinity forms, and we will see the right procedure to tackle them. Here you can't apply L'Hopital's rule directly, because for L'Hopital's rule your limit must be in 0 over 0 form or infinity over infinity form. But here we have 0 times infinity. Here you have to do a simple trick. See, 0 times infinity, if a limit in this form, it can be converted to either 0 over 0 or infinity over infinity. In this way, see, you can take 0 to bottom by this rule. You have 0 times infinity same as infinity over 1 over 0, reciprocal of 1 over 0, which is same as 0 times infinity. Or you can take infinity to the bottom, so you have 0 over infinity in reciprocal. What is this one? This becomes infinity over infinity form. This is going to a smaller number, so 1 over 0 goes to infinity and 1 over infinity goes to 0. So if you have a limit in 0 times infinity, you can convert that limit to infinity over infinity or 0 over 0 by applying this simple rule. Now your limits are in the required form of L'Hopital's rule. Let's solve some questions and see how to apply this. First we have x times sine 1 over x, limit x goes to infinity. See, when you substitute x as infinity, here x goes to infinity means this quantity goes to infinity, and 1 over x, when x goes to infinity, 1 over x goes to 0, and sine of those quantity will go to 0 because this quantity goes to 0. So you have infinity times 0 form. See, here 0 times infinity means infinity can be either plus infinity or minus infinity. So what we will do, we will just change this to our required form for L'Hopital's rule, and you can take any of this quantity, but we will take this happy little kid and let the lazy old man remain as it is. And what is x? We can write it as 1 over x, and we have limit x goes to infinity. Let's check if it is in required form or not. When x goes to infinity, 1 over x goes to 0, so this becomes 0, and top and bottom is 0 also. So this is in 0 over 0 form. So we can apply L'Hopital's rule. So we will apply L'Hopital rule. Derivative of this quantity, derivative of sine 1 over x and derivative of 1 over x. What top becomes? So derivative of sine 1 over x, outer function is sine, so we have derivative of sine is cosine, keep inside, then derivative of 1 over x. What is derivative of 1 over x? This is x to the power minus 1. Derivative of x to the power minus 1 is minus 1 comes outside, and x to the power minus 1 which is x to the power minus 2. So we have x square, minus 1 over x square. So on top we have derivative of 1 over x is minus 1 times minus 1 over x square, and in denominator also we have minus 1 over x square, so they gets cancelled. So you have cosine of 1 over x. Now substitute x as infinity. When x goes to infinity, 1 over x will go to 0, and cosine of 0 is 1, so our limit is 1. Next we have limit x goes to 0 plus x cube ln x. When x goes to 0 plus, from x goes to 0 from right side, this goes to 0, and where ln x go? What is the graph of ln x? This is our graph of ln x. When you go to 0 from right side, your ln x becomes large and large, but in negative, so it goes to minus infinity. So this is in 0 times minus infinity. So what we will do, we will take 1 to bottom by taking its reciprocal. we'll take this happy little kid bottom. So we are not applying L'Hopital here, we are just rearranging the things. So we have ln x in top, and this becomes 1 over x cube. Now let's see what is ln x. Ln x goes to minus infinity and this goes to infinity, so it is infinity over infinity form. More precisely, it goes to minus infinity and it goes to infinity, so minus infinity over infinity, which is also an indeterminate form, and we can apply L'Hopital rule. So what it becomes, derivative of top is 1 over x. This is x to the power minus 3, so minus 3 times x to the power minus 3 means minus 3 minus 1, which is 1 over x to the power 4. So we can simplify this one as, take x to the power 4 to top, and we have x in bottom, and here we have minus 3. So this is x cube over minus 3. This is just let us write here, this is limit x tends to 0 plus this becomes x cube over minus 3. Now put x as 0, so you have 0. This is our limit. Next, let's solve the limits of the form infinity minus infinity form. Here there is no specific rule. By simple manipulation you can change the limit to 0 over 0 or infinity over infinity form, then apply the L'Hopital's rule. Let's first solve. We have limit x goes to 1 plus, then 1 over x minus 1 minus 1 over ln x. First plug in the value of x as 1. You have 1 over 0, 1 minus 1 is 0, 1 over ln 1 which is 0. So 1 over 0 minus 1 over 0, also 0 from positive side because this is 1 from positive side. So you have a bigger quantity from 1. So this goes to 0, this approaches 0 from positive side, and this is also approaches 0 from positive side. See why I am mentioning positive side and negative side, because when you will approach 0 from negative side, then 1 over those quantity will approach infinity from negative side, so it will be minus infinity. But we want infinity minus infinity form, huh? So this becomes infinity and this becomes infinity. We have positive infinities. So this limit is in infinity minus infinity form. What we will do here, we'll just subtract the fractions. In bottom we have ln x times x minus 1, then cross multiply ln x minus x minus 1. Now let's see, substitute the value of x as 1. You have 0 here, 1 minus 1 0, so 0 on bottom, on top, and in bottom we have 0 times 0, so 0 over 0 4. Now it is suitable for L'Hopital's rule. Let's apply L'Hopital's rule. Derivative of ln x is 1 over x minus derivative of x is 1, and this is minus 1 minus, which is plus 1, derivative of plus 1 is 0. So this is it. In top, in bottom we have product of two functions, so we will apply the product rule for differentiation. Derivative of ln x is 1 over x, and keep x minus 1 as it is, then plus keep ln x as it is, and then derivative of x minus 1 which is 1. So what we have on top, it is 1 minus x whole divided by x, and in bottom we have x minus 1 plus x times ln x whole divided by x, and these two x can be cancelled. So what we have, this becomes limit x goes to 1 plus 1 minus x divided by x minus 1 plus x times ln x. Now put x as 1, we have 0, this is 0, this is also 0, so 0 over 0 form. Let's apply L'Hopital rule again. What it becomes, the derivative of 1 minus x is just minus 1, derivative of x minus 1, that is 1, plus product rule, keep x, derivative of ln x is 1 over x, then plus derivative of x is 1, ln x keep as it is. So what you have now, you substitute x as 1. What you have on top, that is just minus 1, and 1 plus this is 2 plus this is 0, so answer is minus 1 over 2. This is our limit. Let's solve another limit of the form infinity minus infinity, limit x goes to infinity, I have ln 4x square minus 6 minus ln minus x plus 3x square plus 5. When x goes to infinity, this 4x square dominates here, and this will go to infinity because minus 6 is just a finite number. And when this quantity will go to far ends of the universe, ln of those quantity will also goes to infinity. And here also the dominating term is 3x square. The highest power will dominate when x goes to infinity. In any polynomial, the highest power term will dominate. Here 3x square dominates. When x goes to infinity, this will go to infinity. So ln infinity also go to infinity. So this is in infinity minus infinity form. Here what we will do, we will use the property of logarithm. This is just ln 4x square minus 6 divided by minus x plus 3x square plus 5. And when you have any continuous function, when you have logarithmics, exponential, trigonometries, then you can take the limit inside. So this is ln limit x tends to infinity 4x square minus 6 whole divided by minus x plus 3x square plus 5. Keep in mind, when you have continuous functions, you can take the limit inside. When you have logarithmics, exponentials or trigonometries, then you can take limits inside because those are continuous functions. Now we have to deal with this limit. So let's check in which form our limit is. When x goes to infinity, this will go to infinity, leading term. This is dominating term. This will also go to infinity. See, here you can apply L'Hopital's rule, or by just dividing with x square, you can find the limit of this term. But we have enough of L'Hopital's rule. Let's just divide the numerator and denominator with x square. Divided by x square. Because if you will apply L'Hopital rule, you have to apply L'Hopital rule twice. But in this method, we will get our limit quickly. So this becomes 4 minus 6 over x square. We are dividing x square with each term. So minus x over x square plus 3x square over x square plus 5 over x square. This is our limit. So what it becomes? Bottom we have, this is minus 1 over x, this is 3 plus 5 over x square. And when x goes to infinity, this quantity will go to 0 because x square goes to infinity, and that is in denominator. This will also go to 0 and this will also go to 0. So you have 4 on top and 3 on bottom. So this becomes ln 4 over 3. This is our answer. Now let's solve limit. When x goes to infinity, the function is x cube minus x. When x goes to infinity, x cube goes to infinity, x also goes to infinity. So this is in infinity minus infinity form. What you have to do here, you don't have to apply L'Hopital rule. Just take the x outside. So you have x times x square minus 1. And when x goes to infinity, this quantity goes to infinity. This quantity also goes to infinity because x square goes to infinity and you are taking out just 1. So this is infinity times infinity, which is not an indeterminate form. Infinity times infinity is infinity. In first of the video, we have seen 0 times infinity. Now we have seen infinity minus infinity. Now we are ready to deal the limits which are in these two forms. And if you have any doubt, please comment in comment section. I will try my best to make a separate video on those topics. And till then, thank you.